So here we're given that from the 5 points A, B, C, D, and E on the number line above, 3 different points are to be randomly selected. What is the probability that the coordinates of the 3 points selected will all be positive? So if you look at this, A is negative, B is negative, C is positive, D is positive, and E is positive. So we have 3 positives and 2 negatives, but in total there are 5 in number. So the probability of the first selection being a positive number has to be 3 out of 5. Okay, and because we can't draw the same number again, they all have to be different as stated clearly in the question, 3 different points. That means if the next one is going to be positive again, that means we can easily just randomly knock off one. Okay, so we are now left with 2 positive and 2 negative. So the probability of picking a positive again will be 2 out of 4. Then we'll knock off 1 again, and the next will be 1 out of 3. And if you solve this out, 3 will cancel 3. 2 here, 1. 2 divided 4 is 2. So this is simply 1 over 5 times 2, which is 10. So this is the probability of picking 3 different positive numbers. So the answer here is A. For this question, in a distribution of 850 different measurements, S centimeters is at the 73rd percentile if there are 68 measurements in the distribution that are greater than Y centimeters but less than S centimeters, then Y is approximately at what percentile in the distribution? So what you have to note here is that you just draw a line. One goes from 0 to 850, which is the distribution, and the other goes from 0 percentile to 100 percentile. Okay, and we are told that X centimeters is at the 73rd percentile. So this is X, and this corresponds to 73rd percentile. Okay, and we are told that Y is 68 measurements below X, right? So this is Y, and this is 68. So we're looking for this particular point. We don't know what percentile Y is. So the easy thing to do here is to determine the equivalent of this 68 to the percentile. And how do we do this? This is simply 68 divided by the total, which is 850 times 100 over 1. And this will give you exactly what you need. And if you do this, this will give you simply 8%. Okay, this is what's going to give you 8. So if this is 8, that means this here is equivalent to 8. So that means the difference between the X percentile and the Y percentile is 8%, right? So which means that the box here is simply going to be 73 minus 8, which is 65th percentile. So this is 65th percentile. And the answer to this is simply E. And that solves our problem. For this question, for a certain distribution, the measurement 12.1 is 1.5 standard deviation below the mean. That simply means if this is 12.1, this is equals to the mean. It is 1.5 standard deviation below the mean. So we use a negative. Okay, and the measurement 17.5 is 3.0 standard deviations above the mean. So that means if this is 17.5, this is simply mean plus 3 standard deviation, and S is our standard deviation. We don't know what it is yet. Above the mean. What is the mean of the distribution? So we are trying to find what is M here. Okay, and this simply looks like a simultaneous equation. Okay, and we can apply elimination method, but before we do that, let us multiply this by 2. Let's multiply this by 2, and if we do so, it's going to yield, this would be 24.2 is equals to 2m minus 3x. So with these two now, we can easily add these two equations, and if we do so, we're going to have this to be 41.7 equals to 3s minus 3x it gives us 0. So we now, if we divide both sides by 3, divide this by 3, we'll obtain that m is simply 13.9, and this is your mean. This is what you're looking for, and that is simply B, and that solves your problem. For this particular question, we are given that set A has 50 members. So set A has a total of 50 members, and set B has a total of 53 members. Okay, at least 2 of the members in set A are not in set B. That means within set A, at least 2 members in A are not in B. That means 2 members could just be in A, while 48 members in A can also be in B. But or 3 members can be in A, 47 will also be in A and B. But at least we know that 2 members are not in B. I don't know if that makes sense, but I'm going to draw this in a Venn diagram, and that will make more sense to us. Okay, so which of the following could be the number of members in set B that are not in set A? So let's just draw the Venn diagram. This is A and this is B. So let's say number of, this is B, people that are in A and B, let's call them X. That means what will be left in A is 50 minus X, and for B it will be 53 minus X. Okay, but we already know that 50 minus X cannot be less than 2. It is stated here, at least 2. 2 of the members in A are not in B, so at least this number can only be 2 and more, right? I mean, this number here can only be 2 and more, but it can't be less than 2. So let's put that in an inequality. This would be 2 has to be less or equals to this number 50 minus X, and this has to be less or equals to 50, because at the end of the day, all the members in A can all be just in A but not in B. That's why it is less or equals to 50. But what we are looking for here is, the question is, which of the following could be the number of members in set B that are not in A? And that is here, that is the region, members in set B that are not in A. So we're trying to find 53 minus X. And if you look at what we have here already, that is true. If we add 3 to each side, we are going to get 53 minus X, and that will give us what we're looking for. So we can add 3 here, add 3, and add 3. And this will simply be 5 is less or equals to 53 minus X, less or equals to 53. So now we have what we are looking for, which is B only, right? So what this means that it can only range from 5 to 53. So it can be 5 or more and then be 53 or less. So if we look at this, we'll see that this doesn't fall in the range. This is 5 or more, this is 5 or more, less than 53, 5 or more, 5 or more, and this is 53 or less. So the solution to this problem is B, C, D, E. Alright, and I hope that made some good sense. So here we're given that R is a list of 15 consecutive integers and T is a list of 21 consecutive integers, and the median of the integers in R is equal to the least integer in T. So this is R, has 15 integers, and because it's all, we know that the median is going to be the 8th term, right? So to the left we have 7 numbers, to the right it will have 7 numbers, and the 8th term is the median, and they say this median is equal to the least integer in T. So if this next one is T, this one is T, has 21 numbers, and this is T, that means this corresponds to whatever number we have here, right? So if the two lists are combined into one list of 36 integers, how many different integers are on the combined list? So we're looking for different integers, and because these are all consecutive, that means from here to this point they are all going to be the same, right? And so what we have here, so that means the different numbers will be whatever we have here from here to here, and whatever we have from here to this point, They are double but just different, and then here to here, right? So this has 7 different numbers. From here to this point, this is 7 plus 1. This will have 8 different numbers, and this whole for t is 21 in number, minus 8, that will give us 13. So from here to here is 13. So we combine all this together, this will be 7 plus 8 plus 13, and this is equals to 28 different numbers, if that makes sense, because the median of R is equal to the least number in T, and that's how we get 28. But in total there are 36, but different numbers are 28 in number, and that is option C. So for this particular problem, we are given that the figure above shows the probability distribution of a continuous random variable x. For each of the 5 intervals shown, the figure is giving the probability that the value of x is in that interval. What is the probability that 1 is less than x is less than 4? So we are looking at the probability of this region. Okay, which simply means we're going to add the individual probability of this, and this, and divide it by the probability of the entire distribution. Okay, which simply means what we're looking for here, the probability here is simply 0.3 plus 0.32 plus 0.14 all over the total sum, which is 0.18 plus 0.3 plus 0.32 plus 0.14 plus 0.06. okay, and if you add this all up, you get that the top is going to give you 0.76, and the base will give you 1.0, and this is simply 0.76. So the probability of this between 1 and 4 is simply 0.76, and that is the solution to your problem. Yeah, and that solves your problem. So please, if you have questions on how I arrived at each of these problems, please do let me know, and I'll be very willing to give you more explanation or do another video to make it clearer to you. And if you found this helpful, please like, share, and subscribe. Thank you.